Hi everyone, Andy Klein here. Got a little bit of downtime on a business trip. I'm in a hotel room right now, but that actually gives me an opportunity to do something I've wanted to do for a while. And that's to tell you about three inventions, three product development ideas that at one point I was really excited about. Each one of these I thought had potential, but they all failed. So this is I think healthy unburdening. If I kept these secret, I think part of my mind would always think, well, maybe I could bring this back. Maybe there's still some potential. And I think it's healthy to kind of cut out the dead wood, just share some things, tell the story, and really put it to rest of this is not going to be something that I put effort into. So here we go. So the first idea, and this one actually happened right after the blade, in the middle of 2015. I was thinking about the problem of hand drilling, using a drill and trying to get a hole drilled perfectly plumb just by hand without any kinds of guides or anything. So I started thinking about geometry that might help. And kind of the backbone of this invention, the geometric property that I took advantage of is this. Consider a cylinder and a cone, okay? If they are both centered around the same axis and that axis is perfectly plumb, they intersect the surface with two concentric circles. And so here's a cross section of the same thing. You see the circle and the cone. When they're perpendicular to the surface, the gaps at the edges are the same, but if they're not perpendicular to the surface, now all of a sudden the cone's outside of the cylinder on one side and inside on the other. So they're not intersecting in two concentric circles anymore. Okay, so how to take advantage of this? What I did is I built this disc that goes on the chuck of a drill, and I mounted two lasers in that chuck. One laser is pointed straight down. When it rotates, it makes a cylinder. The other is at an angle, kind of skims the bit to get a steep angle on the cone, which makes this work better. So when they rotate, they make that cylinder and the cone. If the bit is perpendicular to the workpiece, then they make concentric circles. If not, they skew and the circles cross each other. And it's a very easy thing for your eye to pick out, much easier to pick out than the drill bit, looking at the drill bit itself. So pretty cool, right? Now the way I usually approach this, to keep the cost down, file a provisional patent, maybe talk to some companies, maybe release the video. Now for this one, after I had already built this and I was really excited about it and I had already actually filed the provisional patent, I did one more patent search on my own. I used a few different keywords. I probably should have been more thorough up front. But I found someone who had a patent for something very similar. Now, I looked at his concept and the way he was approaching this. He was going to have a separate disc chucked up into the chuck of the drill to hold the lasers. He hadn't come up with the idea of mounting up on the chuck. So his conception of this invention involved two separate chucks, one chucked into the other, and then you chuck the bit in, and it seemed a bit more unwieldy. I liked mine better. Now, he had one broad claim in his patent that my lawyer told me was problematic because it encompasses any rotation assembly of lasers to do this thing. Mine would fall under that. But what my lawyer said is, you get your provisional, you can't practice it, but he can't necessarily practice the improvement, get rid of the disc, mount up on the chuck. Maybe you can do a partnership. So I tried to do this. I approached him. We talked for a little while, but he wasn't interested in trying to partner with me, and ended up launching his website on his own with what I think is an inferior concept with this disc. I think it would have done better. I haven't heard much about this since he went live with it. It's called Bullseye Board. You can check it out, link in description. But what can you do? He was there first. That's how the patent system works. It's worked in my favor. I'm glad it's there. I'm glad it's there for this gentleman. And since I've let my provisional lapse, now he doesn't have to partner with me to make the improvement. So sometimes these things don't work out. I was actually very lucky that the first idea that I put a lot of effort into, the blade, is the one that actually did make it to the market. That gave me a lot of confidence to keep trying. And that was just kind of dumb luck. I could have come up with a bunch of good ideas that stalled out, and that ends up killing your confidence, and you stop trying. So I'm very fortunate that I had the commercial success early. So the next idea that I want to talk about was a bandsaw tool that had two purposes. So the first purpose was a really low friction point fence. with ball bearings instead of just a piece of wood or something. Bearings are going to be better, lower friction. And then the next, and I think more interesting way this could function, if you release these two screws, those bearings will move on springs. So it's a springboard. If you want to use a standard fence, then maybe use a point fence for some cuts if you're just ripping down the middle. But if you're cutting a bunch of veneers, you want to use a standard fence, you need a good springboard, a good really low friction springboard. This would be great for that, because if you have a 4-inch long standard springboard, that friction starts to get to be a little difficult to push the material through. And with rotating bearings, you don't have that problem. So I was pretty excited about this one. I really thought somebody would pick it up. I talked to a few companies, just couldn't get anybody interested enough. Some of the comments I got back were, well, bearing point fences already exist. There's different solutions for feather boards. They're not all that great. Volume sellers, this would take some development. We just don't know if the payback's going to be worth investing in the product, and blah 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 blah. So yeah, what can you do? All right, so the last idea that failed has to do with finish and getting finish out of a can. Now, some people, if you've been watching my channel for quite a while, might remember that I had kind of an upside down hanging can finish discharge idea. I wanted to build on that and actually kind of couple that idea with the Bloxygen product that shields the finish from oxygen with inert gas. I thought, well, what if you could actually use Bloxygen to discharge a finish? You don't even need to take the lid off. And if you want to get a small volume of finish, it's just a real easy thing to do. So I built this lid with a couple valves in it. You just open the valves, put a little Bloxygen in. There's a dip tube that goes down to the bottom, so that the Bloxygen pressurizes the headspace, forces the finish up through that dip tube, and you can just discharge a little bit. Seems pretty cool. So what happened with this one? Well, this one was more of a technical challenge that I'm just to the point where I think it's solvable. The challenge is making the valves and the seals compatible with every possible kind of finish, making that discharge piece geometry such that it doesn't clog up with finish. It's got to be durable and reusable, because you don't want to buy a new lid for every can of finish. You need to be able to reuse it, which probably means it needs to have some ability to break down and clean it. So this is a very specialty sort of valve that you end up needing to have to really make this work. And that's going to be expensive. It's going to be really expensive. I think to be appealing, this product is going to have to be, I don't think people are going to want to spend more than $10 for this lid. And to try to get the valve manufactured for, that means just the valve itself is going to have to cost you only a couple bucks to make. For this to be profitable, and I think a specialty valve with all these fiddly little requirements is going to be a heck of a lot more expensive than $2, especially in the kind of volumes that I'm talking about. If there was potential to sell 10 million of these lids, then maybe with scale manufacturing and all the advantages of a large volume like that, maybe you get the price down that low. But for new things that are new to the world and volumes are going to be small, man, you've got to deal with much more expensive parts than you would otherwise. So I just don't think it's possible to have this thing made at a price point that's ever going to be appealing. So this one and the other two are out. I'm not going to worry about these anymore. I'm not going to put any more effort into them. You may see them in videos in the future as I use all these solutions, because I still like all of them. But I'm not going to try to turn them into products. Now, don't fear. I've got lots of other ideas that are shaping up to be more successful in the future. So look forward to more. I hope you found this interesting, and I hope if you're trying anything on your own, any kind of entrepreneurial effort or any project that has a level of challenge to it, that you get some perspective on if you want to be successful, you're going to have to try a bunch of things. They're not all going to work out. Staying confident and believing that you really can make something happen is important. You know, if I had all of these failures up front, and the blade was going to be my 7th idea instead of my first that I really put effort into, I'm not sure I would have gotten to it. And that's a lesson I'm lucky to learn because I had that success early. Thanks for joining. I still never know how to end these videos.